Hello friends, welcome to SR Physics Academy. Today we are going to discuss about what is gradient, divergence and curl of function. Here del operator. Del operator is a vector differential operator which has a significant role in electromagnetics for finding gradient, divergence, curls and Laplacian. Before we are going to discussing del operator, first we should know that what is scalar quantity and a vector quantity. Here a scalar quantity is a quantity which is defined by only magnitude. Some example of scalar quantities are mass, charge, length, distance, volume, speed, time, temperature, etc. Vector quantities are those which have both magnitude and direction. Some examples are velocity, force, displacement, momentum, acceleration. So here, del operator is the collection of partial derivative operators. That means del, the symbol is del equal to dou by dou x I vector plus dou by dou y j vector plus dou by dou z k vector is commonly called the del operator. Its another name is nebula. Here the symbol of nebula is represented by inverted triangle. This is we called as del. There are three types of derivatives associated with the del operator. Here the del we are divided into two parts. One is vector field and another is scalar field. So now what is scalar field, that we can write it when del dot, that this is the scalar function, this is the small letter f. So when the del operator with the f function, the scalar function, then we can say that gradient, that is we can say gradient f. And vector field, there are two types here, del dot f, that both are vector here, this is del cross f. Now, so in these two, this is we can say that this is the dot product, okay. That means when the dot product of vector f, and this is the cross product of del and f vector. So here the major difference between dot product and cross product is that the dot product is the product of magnitude of the vectors, and the cross of the angle between what will come, it is the cos theta. Now where the cross product is the product of the magnitude of the vector, the sine of the angle, that means here sine angle will come, they are subtended each other. Now here the del operator, already just we told you that del, the symbol is del equal to dou by dou x I cap or I vector, dou by dou y j vector plus dou by dou z k vector. This is the gradient of scalar function. So just now we discuss about that what is gradient. Gradient means it is nothing but the del dot, that is scalar function, it is f. So here the gradient of the scalar function, that we can say that the gradient is what you get when you multiply del by a scalar function. We will get the resultant of the gradient is the vector field. So we can say that the gradient operation turns a scalar, the result, okay, the gradient operation turns a scalar field into vector field. Now, that is the vector field. There are, we can called two types. What is that? Divergence and curls. First, we will discuss about the divergence. So here, the divergence of vector function is scalar quantity. So here it is coming the dot product. Okay, the dot product of del into what? The vector f. So in this case, the divergence is what you get when you dot del with the vector field. So the resultant of the divergence is scalar function. So here we will get the resultant what? Scalar function. So when the gradient of this one, what is the resultant? We will get the vector quantity or vector function. But when the divergent operation turns into vector field, the resultant we will get scalar quantity. Next one is curl. So here the curl is what you get when you cross product. Okay, cross with the del with the vector field. The resultant of the curl is vector field or vector quantity we will get. So we can say that the curl operation here turn a vector field into another vector field. So now, so once more I am explaining here. Here what is the resultant? The resultant of the gradient function, what we will get? Into the gradient function of scalar field into vector field. So here this is the vector function. Okay, the divergence turn into vector field into scalar quantity. So in this case, here that the curl operation, this is, we can say that when the del cross into vector f, then we can say that this is curl, this is divergent, okay, this is gradient. So in this case, what is the resultant will come? This is also both are vectors. So after the resultant, after the operation turn vector field into vector quantity. So we will discuss one by one. Now first is gradient of scalar field. So what is here the gradient of? The gradient we know that it is a vector quantity. So then next is the gradient is applied on scalar quantity. So in this case the gradient is the differential operator by means of what we can associate it with the vector field with the scalar field. So this is the vector, del means here the vector and this is the scalar quantity. So now even we can write it, the gradient of the scalar field means we have to write it del vector into small f or phi, we can write it, okay. So instead of f we can write it phi also, because here it is a no vector, that is the meaning it is a scalar function. Now here f is a function of 3 variable of gradient vector A, so we can write it. So already we know that what is del? Del equal to dou by dou x I vector, dou by dou y j vector plus dou by dou z k vector. But here we are, what we are adding here means what we are multiplying here, this is f vector, okay, sorry, f scalar function. So in this case, so instead of this we are what we will get here, dou f by dou x I cap plus dou f by dou y j cap plus dou f by dou z k. So now, so let us take this example here. The gradient always point. So here what happened? The gradient tells how much something changes. Okay, what is the meaning of here? The gradient means it tell, the simple example we can say that is how much something changes as you move from one point to another. So now a gradient gives the rate of change of the function of x, y, z in any direction you take it in space. So for example, E equal to minus gradient V. So here what is the meaning of this? Here the gradient always point in the direction of maximum, what is that, rate of change of a field. So here if you take the example intensity of electric field. Okay. So this example, so here we know that intensity of electric field. So electric field is the vector quantity. So is the gradient of potential V. So potential V is here what? It is the scalar quantity. So with the negative sign. Okay. So here the negative sign indicate that the direction of field intensity is opposite to the direction of increase of potential. Now, gradient of scalar field at any point gives the magnitude and direction of the maximum rate of change of field. So, just now I told you here, the gradient means what? Change in the height by the change in the horizontal difference. So, here, okay, now you take the example of here the room heater. Okay, in this case, the room heater, it is near, what will happen? It is very hot. Okay, it is a hot, it is there. But if you move away, so they compared to this area, okay, compared to this location, the heat will get here less. That means here the rate of the magnitude and even the magnitude and direction of the maximum, the rate of change of the field. So it will show the gradient of the scalar field at any point if you take gives, there it is the magnitude and direction of the maximum rate of change of the field we can calculate. For example, okay, here, so as we know that here this is what we have to calculate here, gradient. How to calculate the gradient? In this case here, this is the positive gradient, this is negative gradient. So how to calculate? So in this case, here we know that the gradient means what? Change in height by the change in horizontal diffusion. Okay. So in this distance here, the line is here less steep. So the gratitude is also, that means here the gradient is small. Whether suppose the more steep, so what happened? The gradient is more. So when the gradient or slope is measured as how much far up, okay, that we can calculate. So we have gone, or compared to how far we have gone across. So here we can say that it is a gradient. Okay, here this is how much rise up here, that means up 3, and here it is across, we can say that 5, for example 5. So that means gradient equal to up by across, okay, run by rise. So we will get it 3 by 5. So in this case, what is the gradient? 0.6. And if you take the negative gradient, in this case what happened? The slope is coming down. This is going up. That means it is the positive gradient. This is the coming reverse. That means down. So we can say that this is the negative gradient. So in this case, here what is the height here? For that means it is the reverse. Okay. So minus 4, and this is the distance is 2. So the gradient equal to up by what across? So minus 4 by 2. So we will get minus 2. Next we know that how the flat surface of the gradient. So here flat surface means nothing is there. So it is the straight. Okay. There it is a no up and no down. So in this case we can say that here the across is here, but up is no. The up is no means it is the 0. So gradient equal to 0 by 5 we will get 0. That is means in this case the gradient is 0. In this case, how much it is up, how much it is across, we can calculate easily gradient. That means positive gradient, this is the gradient, negative we will get. Now we will discuss about the another example. So in this case, if f equal to x, y, z, so we know that this is f means it is a scalar function, a function of x, y, z. This is not a vector. So we have to calculate, find gradient. So this is the meaning of what? It is the gradient f. That means when the dot, when the what is that? Del into f scalar function. So in this case, so how we will calculate? Here we know that it is the del f, we can say dou f by dou x I vector, dou f by dou y j plus dou f by dou z k vector. So in this case, what we will get there, that is before just we explain what it is, what is the resultant we will get. Okay, so here the gradient operation scale, that is the when the gradient function, so the gradient operation, it is the term we will get scalar into vector field, because this is a one is vector, one is here scalar. So after result we will get vector function. So here, so now we know that x, y, z, is it? So when we will differentiate with that is differentiate, already you know that. So in this case, instead of f we are putting here x, y, z. Okay, with respect to x. In this case, dou f by dou y, instead of f we are putting x, y, z. So substituting the instead of f value we are putting x, y, z. And here dou f by dou z, that is dou by dou z of f value x, y, z. Now just we are differentiating with respect to x of this term. Here I am written directly here. So in this case, see dou f by dou x. Okay, with respect to x, what we will get here? Y z. So we got it y z I cap. Okay, I cap means I vector. Next is here, in that is dou f by dou y. With respect to y, so that y will go, then this x z. So we will get x z and dou f by dou z. So in this case, with respect to z, so the balance is xy. So we will get xy, and what it is the here, that is the k. Okay, k is the directions. So in this case, direct vector. So we will get y z I plus x z j plus xy k vector. So now it is clearly you understood what is it. When what is the resultant vector with the gradient f, we will get the resultant vector is vector field. Okay, vector function, we got it. Next is divergence of vector field. So what is divergence? The divergence of f can be written symbolically as the dot product of del. Okay, that we know that. So how we can write it? Divergent of f. Okay, this is also vector. So divergent f, we can say that divergent del dot f. So in this case, you have to remember that when the what is the resultant answer? That means here the divergent operation turns a vector into scalar field. So divergence of vector quantity indicate how much vector quantity spread out from the certain point. So that is we will discuss one by one. So how we can write it? Divergent f equal to, we can write it. So here a capital F, that means vector. So what are the function is here? The f we can write it. For example, f1, f2, f3 function is there. So we can write it dou f1 by dou x with respect to x, dou f2 by dou y. That means here the y, and dou f by dou z. So in this case, the divergence of vector field is a what? Scalar function. So we will get the answer, it is a scalar function. So we will discuss here the divergent F we can classify it into three categories. One is positive divergence, next is negative divergence, and third is zero divergence. So in this case, so here what is divergence? Divergence means it is if you take the flux density, the amount of flux entering or leaving a point. Okay. So that means the rate of flux, what is that here? Expanding. Okay, positive, that is we can say that it is the positive divergence, and in this case here the flux contraction. Positive contraction. So in that is negative divergence. Next is the zero divergence. So in this case, the positive divergence means if the vector field is increasing in magnitude, okay, that is increase in magnitude, then as you move along the flow of the vector field, okay, this is actually what happened. If the vector field is here increasing, then we can say that this is the positive divergent. That means away from the point. If you take this is a central point, this or the point is away from the point, this electric field, then we can say that this is positive divergence, and this is negative divergent. Negative divergent, it is the converging. What is converging here? The decreasing in magnitude as you move along the flow of the electric field. Okay. So this is, we can say that negative. That means if you take the point, it is what is that converging towards the point. This is away from the point, this is towards the point. So away from the point we can say that positive divergence, and converging towards the point we can say that negative convergence. Next is zero divergence. If the vector field, okay, this is, see, look at this arrows here. If the vector field does not change in magnitude as you move along the flow of the vector field, then we can say that the divergent is zero. So that geometrically we can say the measure how much a vector diverges at a point. Okay. Now once more I am explaining here what is positive divergent when the field is spreading out, and what is negative divergent when the field is converging at that point. Okay. So now zero divergence means that if the vector field does not change in magnitude as you move along the flow of vector field, then we can say that here it is no, what is that, converging, no direction, nothing. So here that is a zero divergence. Then one more, you have to remember that a vector function f is said to be solenoid. When it will come, when the solenoid time, then we can say that del dot f equal to 0. When the del dot f equal to 0, then we can say that a vector function f is said to be solenoidal. This is all the one more question they can ask it. Now, next we will discuss example. So, in this case, they are giving a function, what is that, x, y, z. So, x, y, z, what is that giving direction? X is that I vector I plus x, y is that j minus y square k. Find what you have to calculate divergent f. We know that when the divergent f, what we will get it? We will get it scalar, result is scalar function. Now, so we know that divergent, what we will write it? Del. Del means dou by dou x I vector, dou by dou y j vector plus dou by dou z k vector. Now, what they are giving here f? F is nothing. They are giving in the question what it is, x is that I vector, x, y is that j and y square k. So, that is we have written here del dot f. Clear? Now, just we are multiplying because it is a dot product. So, dou by dou x. Now, so already we know that here I into I equal to 1. Okay. J into j equal to 1. K into k equal to 1. When it is I into j, what it will come? We will get it 0. So here I into I. So I into 1. So dou by dou x. Then what is the value here? X is z. Okay. Now dou by dou y and multiply xy is z. Next is dou by dou z. What it is there here? Y square. So here how it is coming here? Minus y, because the sign is here minus y square. Other two term function, it is the plus term. So here after differentiating, so in this term it is with respect to x, we will get only z. Okay. Now dou by dou x of here also with respect to x. So we will get it x, sorry, this it will come y dou by dou y. So we will get it x, y and y, it is a difference. So x into z we will get. Here it is a z term. Okay, this is z term, because the question dou by dou x, dou by dou y, dou by dou z. Okay, so here it is minus y square. So here no z term, so it will be cancelled. So we will get the answer z plus x z. So this is also we got it. Our result is scalar function, scalar. Clear? So here see, that is proof that, because here this is the vector, when the vector product is means multiply or product of del into vector field, we will get the answer here scalar field, scalar function, because here no direction it is showing. Now next is curl of vector field. So we know that it is the cross product of del and f vector. Now what is curl of the vector? The curl of the vector quality indicate that how much the vector quality curls or twist. Okay, how much it is a vector quality curl or twist around. Okay, this is we can then we can calculate the curl of the vector field. So in this case there are two types here. One is rotational, another one is irrotational. So in this case, there it is a rotational. What do you call the rotational here? There it is clockwise direction. This is anti-clockwise directions. That is the type of rotational. And this is irrotational, means here it is only the straight line path. So now we will discuss what is rotational. In rotational, what is clockwise? So here this is a positive rotation. Okay, positive rotation we can call it as, okay, this is, you can write it, this is positive. Okay, positive rotation. So positive rotation, then we can say that it is a clockwise. And obviously this is anti-clockwise, means this is negative. Okay, so this is positive, this is negative. So negative rotation is counter anti-clockwise. Now this is irrotational. It is the straight line path. It is not rotating anywhere. So that means when it will come irrotational, when the cross product, okay, the cross product of del into f vector is 0, then we can say that this is irrotational field. So before we learn that is del dot f equal to 0, that we can see that the solenoidal field, and when del cross f equal to 0, then we can say the irrotational field. Then we know that how we can write it, curl of del cross f. So in this case it is a matrix already you learn about. There it is, the del means what? I, j, k, that means matrix form we have written. Next is dou by dou x, dou by dou y, dou by z. And what are the f? Okay, the f function is here f1, f2, f3. Okay, so when you are writing the curl means curl of vector field, it will have to write it, it is a matrix form. So let's discuss with the example. Find the curl of a vector field. Here f function of here vector f, we have written x comma y comma z. So what they are written here, 2xy I vector plus x square plus z square j vector plus 2zy k vector. So in how to calculate the curl of vector field. So see already we discussed about that what is the resultant it will come when the curl of the vector field it is multiplied with the del, we will get the resultant is only vector function, only vector field. So now the curl of the vector field f is given by, so we know that how to write it, ijk dou by dou x dou by. So there the form may be written f1 f2 f3. So here what is the function they are giving? They are giving here 2xy. Okay, x term they are giving 2xy, and this is f2, instead of f2 x square plus z square, and f3 2zy. So we have written. Now we have to do the cross product. So this term will come here. This is the cross product. So dou by dou x of 2xy and dou by dou x of x square plus z square, and after the cross product we will get it ijk. Okay, even if you take it j, then dou by dou x of this term and dou by dou x of this term. So after the matrix, that is what we get the answer here. So this also same procedure, this is with respect to y, so we will get it, y will go that 2z, and this is z term, so we will get it. After that this is will go 2z only. Now it is how it is coming 2z, because z square, that we will get it 2z. And next is, if you take the j term, there also same procedure with respect to x. Here it is cancelled because here no x term. Okay, in this here no x term, here also no z term, so both will be this cancel 0, and this also here with respect to x, so we will have here x square, that means 2x, and this is z term, it will cancel, and dou by dou y of y is here, so 1, so 2x, so it is a j vector. So next is here 2z minus 2z also 0, and 2x minus 2x equal to also 0, this is already 0, so we got the answer is 0. Hope you understood. Thanks for watching.